Good morning, my dear NEET 2024 warriors. And this session is only for ultra legends, meaning those students who want to study for the last minute and want to get a safe score in NEET physics so that you get your dream medical college. And today's target is, if you are getting very low marks, our target is to get at least 80 marks in physics. So I'm going to make you solve the questions and also explain you the concept behind solving these questions in a very simple manner so that you understand if such a question comes, what is the formula that we have to use. And maybe you would have already seen the formula class. If you have seen the formula class, very good. How to use those formulas, you will understand it today, right? So let's begin with our 0 to 80 for ultra legends. All the ultra legends, mark your attendance quickly in the like section. Yes, please mark your attendance in the like section. Yeah, smash the like button and subscribe to the channel. Yep, good morning everyone. For those of you who missed the formula class, let me remind you, it is there in the videos part, not in the live part, right? It is there right over here. Complete physics formulas revision. You can even listen to the audio, that is perfectly fine, or you can watch the video, that is also better actually. So the PDF of the entire formula list is also attached, right? So that is your formula class. And even Diksha ma'am had done formula revision. Today you are going to have important scientists and the dates in biology, right, by Shreyas Sir and Gopika ma'am. It's at 12 o'clock, right? And tomorrow, remember, morning 7 o'clock is the easy kill direct questions. 50% of the paper will be like this. So you cannot afford to miss that. It's early in the morning, okay? So it's early in the morning. Let's begin. Yes, everybody is ready for the class. So let's begin with the lecture, guys. Okay, this is your Captain Shreyas. Thank you for liking. Thank you for loving me. And let's begin with the lecture. Yes, thank you so much. Thank you so much, guys. And also remember, All India Mock Test Predictor Series mock test is going to be live, and you can give it online as well as offline. Register for it. The link is there in the description, because most of the questions will be exactly like the predictor paper. All you have to do is, as you are watching this particular video, ensure that you are basically, enrolling yourself for the All India level mock test. That's it. And download that paper, or basically give that question paper whenever you can. Preferably try to give it, okay, I think I'll have to go here. Yes, preferably try to give it, at the same time. It's right over here, All India Mock Test Series. Just click on this particular link. Just click on this particular link. It's completely free of cost. These two mock tests are predictor papers. Remember that, okay? All right. So starting off with the first topic, and that is basically your escape speed. Very, very common questions. Every time you will see in the NEET exam, there is a question on escape velocity. What is the formula for escape velocity? The formula for escape velocity is root of 2 gm divided by r. What is escape velocity? If you are on a planet, Pandu and Champa fought. Champa said, Pandu, get lost, never come back. So Pandu gets lost and never comes back. He has escaped the gravity of that planet, never comes back, never returns. You have escaped the gravitational field. Champa Pandu breakup happened. So the speed with which Pandu should go out is the escape velocity. For Earth, the speed is very, very high. It is around 11.2 kilometers per second. So if Champa breaks up with Pandu, she will kick out Pandu at 11.2 kilometers per second. Pandu will never ever return. Keep that in mind. Sometimes this mass is written down in terms of density. This mass is written down in terms of density because mass is density into volume. Density into volume. This is not velocity, this is volume. So volume will be 4 by 3 pi r cube. Sometimes you might be using this formula also in terms of density. Is that clear, everybody? And also remember, when you go really, really far, when you are really, really far, at that far off place, kinetic energy is 0 and potential energy is also 0. Basically, total energy is only 0 at that far, far away place, right? So let's have a look at some of the questions coming up on your screen. Here is the first question. Come on, try to solve this. Try to solve this, guys. Come on, my dear students, try to solve this. Let me, meanwhile, 1 second. This wire has messed up. Just 1 second, guys. You keep answering. Okay, yeah. Yeah, what is it? The escape speed of the from the earth is v. The escape speed from the surface of another planet having a radius 4 times that of earth and the same mass density. What did I tell you? Density related questions can come, right? So escape velocity is root of 2 times gm divided by r. Instead of mass, I can write it as density into 4 by 3 pi r cube. R cube and r cancels, so I will have 8g basically pi by 3, and I will have r square, and I will also have rho over here. I'll have rho over here. Now observe this and carefully tell me, the mass density is given to be same, only the radius is basically 4 times. So in fact r square can even come outside. R square can even come outside, and it will be root of 8g pi rho divided by 3. That is your escape velocity. Can you see escape speed is directly proportional to r. So if the radius becomes 4 times, escape speed should also become 4 times. So the answer should be option 2. Option 2. A lot of you are saying option D. That is wrong. That is wrong. Option D is wrong, guys. Answer is option number 2, which is 4v. Understood? So I have used the concept of mass being density into volume. Mass being density into volume. Got it? This is a common type of question. This was also asked in NEET 2021, just like you can see over there. Next question. There is a black hole whose gravitational field is so strong that even light can't escape. Forget Pandu or Champa, even light can't escape. To what radius should the earth be made, compressed to be turned into a black hole? Even light can't escape means the escape velocity is the speed of light. Escape velocity is root of 2 times gm divided by r is equal to speed of light, which is 3 into 10 to the power 8. I want to find the radius. So square it. So 2 times gm divided by r is equal to 3 square, which is 9 into 10 to the power 16. Since I want radius, bring this people down. So it will become 2 times gm divided by 9 into 10 to the power 16. Now g value, right? 6.67 10 to the power minus 11. Mass of the planet is also known, almost 6 into 10 to the power 24. Substitute the values, you will get the radius. Approximately how many value, or what is the meters value that you are getting? Just see, if you are getting 10 to the power minus 2 meters, after solving this, you should get 10 to the power minus 2 meters is a 1 centimeter. So if you compress earth to 1 centimeter, even light won't be able to escape it. So that is the answer to this particular question. Understood, my dear warriors? Clear? Shall we go ahead to the next one? Shall we go? Yes. Let's go ahead. All right. Very nice. Come on, guys. Concentrate. Yeah. Yes, this is also referring to the topic. I'm giving you the topic and then we are going to the question. Next topic, which sure short questions, bare minimum if you want 80 marks, is Kepler's laws and satellites. There are 3 laws of Kepler if you remember. The first law is that every planet will go around the sun, or the satellite will go around the sun, or the the heavy mass, with that heavy mass being in the focus of the ellipse. Being in the focus of the ellipse. This is the first law. The second law is that your planet which is revolving around the sun, or the satellite which is revolving around the planet, the speed is not constant. In fact, it is such that if you see the area swept by the planet in some time, and you see the area swept by the planet at some other time, that area will be the same per unit time. Delta A, area swept per unit time, is basically a constant. Here it goes very slowly, here it goes very, very fast to cover the same area in the same time. This is the second law, which is the law of areas. And the third law is the time taken to complete one revolution. The time taken to complete one revolution is dependent on what is the average radius, or basically also called as the semi-major length. So, alright. So, the time square is directly proportional to the average radius of that particular ellipse. So, proportional to the cube of that actually. So, t square is proportional to a cube. That is the formula. In fact, if you remember, the actual formula is t is 2 pi root of r cube by gm. This is true if you have something which is going in a circular manner around a massive body. So for a satellite which is going around in a circular orbit, this is the formula. Time period is 2 pi root r cube by gm. If you square both sides, t square will be proportional to cube of the radius. So that is the relationship, right? That is your Kepler's laws. Very good. Awesome. Let's move on to some questions. The time period of a satellite is 24 hours at a height of 6 times the radius of the Earth. The time period of some other satellite whose height is 2.5 times the radius of the Earth will be how much? I think you will have to use Kepler's laws. Think which Kepler's law will you use? Which Kepler's law? Obviously, time period of revolution is asked. So it obviously means you will have to go with the third law of Kepler. So let's go to third law of Kepler. T square is proportional to basically r cube. So T2 by T1 will be whole squared here, and this will be R2 by R1 whole cubed. Now what is R2 and what is R1? That is the catch. Okay. So first of all, R1. The height is 6 RE. Height is 6 RE means the actual distance will be 6 RE plus RE, because the radius of the Earth is itself R, height is 6R, right? So what is the total height? It is basically 7R. Correct. So hence R1 will be nothing but 7 times of R. Same way for the next time, the height is 2.5 R, meaning the total height will be R plus 2.5 R, which will give you 3.5 R. 3.5 R. Is that right? This will be 3.5 R. And this is whole cube. T2, I don't know. T1, I know. The time 1 is 24 hours. So square it. Correct? Okay. So R will get cancelled. 3.5 by 7 is nothing but 1 by 2, because 3.5 into 2 is basically 7. So this will be 1 by 2 whole cube. 1 by 2 whole cube. Let's see what happens next. So this will become T2 square by 24 square will be 1 by 2 cube. What is 1 by 2 cube? It is basically 1 by 8, right? So T square will be 24 square by 8. So T2 will be square root of this. So 24 by root of 8. Root of 8 is 2 root 2. 2 and 2 cancels. So 12 by root 2. So 12 by root 2 will be there. but you can rationalize this, So multiply and divide by root 2, it will become 6 root 2. So 6 root 2, which is option number A, is the correct answer. Yes, that is the correct answer. How many of you got this? Very good, Shinchan. Option A, excellent, Preeti. I want to see the people spamming out here. Come on. Everybody, yes. Make sure that you are conversing in English only. Yes, make sure you doing that. Very good. Excellent. Excellent. Very good, very good. Keep up the Josh. Yes, keep up answering. Very good. Awesome. Let's move on to the next question. The kinetic energies of a planet which is going in an elliptical orbit around the sun are given as shown. AC is the major axis and SB is perpendicular to all of that. Then where is the kinetic energy more? Where is the kinetic energy less? This is a question, I think, based on the second law of Kepler. The second law of Kepler. Come on. Where is the planet going to be slow? It is going to be slow here. Where is it going to be fast? It's going to be fast when it is closer. So which is the most correct option? I think this one. First is, kinetic energy of A is more than B is more than C. Here it is medium. Here it will be medium. Here it is slowest. So kinetic energy is least. Kinetic energy is highest at A. At B it is somewhere in between. So I think yes, it is option number B based on the second law of Kepler. Very good, Kushal. Sinchan, crazy girl. Awesome. Sushmita. Yes, JK. Very good, Caro. Moving on to the next concept, thermal expansion concept. So what kind of formulas are there in thermal expansion? First is the change in length is original length into linear coefficient into change in temperature. This is initial length. Remember that. This is that coefficient. This is that coefficient. This is your change in the temperature. This is your change in temperature. This is your change in temperature. You can also have delta A is A naught beta delta T. You can also have change in volume is original volume gamma delta T. Also do not forget that your gamma is 3 times of alpha and coefficient of area expansion is 2 times of alpha. That is another thing which you should know. Next thing is the thermal stress concept, where you keep a rod in between 2 rigid supports and heat it by increasing the temperature by delta T. Then there is stress developed because the rod wants to expand but the rigid supports do not allow it to expand. So that thermal stress which is developed is Young's modulus into alpha into delta T. Young's modulus into alpha into delta T. So that is the concept which is involved over here. So let's solve some questions coming up on your screen. The coefficient of linear expansion of brass and steel are alpha 1 and alpha 2. Lengths are L1 and L2. If L2 minus L1 is maintained at all the temperatures, if the difference of the lengths is maintained at all the temperatures, which of the following relationships are true? Let's understand what it means. For brass, the length is, let's say, L1. For steel, let's say the length is L2. Okay, this is basically your length over here. This is, let's say, your L2. Okay, they have different coefficients, so they will expand maybe differently. But I want to make sure L2 minus L1 is same. L2 minus L1 is basically this one. This is L2 minus L1. Means what? Whatever expansion occurs here should be also the expansion which occurs here, so that the difference between the lengths remains the same. The difference between the lengths remains the same. That means the delta L1 should be equal to delta L2. This was asked in NEET 2019. So what is the delta L2? Delta L formula I just told you, right? What is it? L naught alpha delta T. So it is L naught. L naught is L2 alpha delta T, right? But this alpha will be alpha 2. That length, that alpha, change in temperature same. That's why these numbers have come 2. Over here, this will be L1. This will be alpha 1. This will be delta T. Delta T cancel. Delta T, can you see, my dear students? It is getting cancelled. Very good. So L1 alpha 1 is L2 alpha 2. It is nothing but option number A. Excellent if you guys got it. Very good. A for AIMS. A for AIMS. Proud of all of you, my dear students. Perfect. Moving on to the next one coming up on your screen. The value of coefficient of volume expansion of glycerine is this much. The fractional change of density. Looks complicated question. Don't get scared. Shreyas Sir is here. Why worry when Captain Sir is here? Okay. So let's understand the value of coefficient of volume expansion. That means gamma is given to you. The change in the density of the glycerine is asked. Change in the density of glycerine is asked for change of 40 degrees Celsius. Okay, let's understand it. Change in volume is original volume V naught into gamma delta T. Is that right? So therefore, delta V by V naught is nothing but gamma into delta T. Now we know that density is mass by volume, which is mass into volume raised to -1. Believe me, this is actually a question of errors. Density is dependent on volume raised to -1. So the relative change in density is relative change in volume into the modulus of the power, which means it is just delta V by V. Oh, wait a minute, delta V by V is gamma delta T. So why not put it as just gamma delta T? Oh, do I know the value of gamma? Why not? 5 into 10 to the power -4. Do I know the value of delta T? Yes, it is 40. So what is 5 into 4? 20. And 1 0 there. So 2 zeros. So it will become 2 into 10 to the power -2. So it should be option C for Captain Shreyas. It's not just C, it's C for Captain Shreyas. Oh, no. It is not Baswa sir, it is Captain Shreyas for this question. Be little careful. Yes, option C. Understood? Clearo? Shall we go ahead? So there was the concept of units, dimensions and errors, meaning whenever a quantity is dependent on multiple quantities and the powers are raised as follows, then the relative error in that quantity is the multiplication of the powers modulus into the relative error of that quantity. If mass was there, then you would also have plus delta m by m into 1. If more quantities are there, that powers modulus into the relative error. Those things will just get added up. Remember, that is error combination. Alright, so this is the type of question that you can get over here. This was a short topic. Boltzmann law. All the topics that I am giving you today are easy peasy, lemon squeezy, sure shot for your NEET 2024 physics exam. That means if you practice these models of questions and these topics and the formulas, 100% guys, you will get the bare minimum score. Stephen Boltzmann law is all about radiation. Any body at temperature T will radiate energy, and the rate at which the energy is radiated is nothing but E sigma A T raised to 4. E is your emissivity. Sigma is your Stephen Boltzmann constant, which is 5, 6, 7, 8, and put decimal here and into 10 to the power minus. So that is sigma. A is area, T is temperature. That is your Stephen Boltzmann law. This is the rate of energy emitted from it. Remember, some energy might also get absorbed by it. So some energy might also be getting absorbed by it. That is also possible. So the rate of energy which is basically being absorbed will be, instead of emissivity, you will have A, you will have sigma, you will have A, and surrounding temperature raised to 4. This is the temperature of the surrounding. This is the temperature of the surrounding. A is called as absorptivity. And also remember, using Kirchhoff's law, absorptivity is emissivity. The example for a black body, it emits the most, so E is 1. It absorbs the most, so A is 1. So good emitters are good absorbers, bad emitters are bad absorbers. That is your Kirchhoff's law. So E is also equal to A. Keep that in mind. Yes, very good. Let's move on to some questions coming up on your screen. Here it is. There is a spherical black body and radius is given. Power at which it is emitting, radiating is given at 500 Kelvin. Radius is halved. Temperature is doubled. Then the power radiated will be direct application of your Stephen's law. The rate at which energy is radiated. So dE by dt is E sigma A T raised to 4. So E sigma 4 pi r square T raised to 4. So basically rate 1 by rate 2, or I can just put dE by dt for the first upon dE by dt for the second. See, all these people are constants, only R and T are not constants. So it will be R1 by R2 whole raised to 2 and T1 by T2 whole raised to 4. I want to find the new power radiated. I know the old power radiated was 450. So I want to find what is dE by dt in the second case. Radius ratio 12 centimeters has been made into half. So R2 is basically half of the previous one. So this is basically 2:1 ratio. This is half of the older radius. So square it. Temperature is doubled. So T2 is a double of this one. So 2 by 1 and this is raised to 4. So 2 square and 2 raised to 4, 2 raised to 2 will be here. So naturally your dE by dt in the second case will be 450 into 2 square, which is basically 4 times, right? So it should be 1800 watts. 1800 watts. See how many of you got it? Yeah. Yes. Okay. I hope this is clear. I hope this is clear. Everyone? Understood? All right. All right. Okay. Very nice. Yes. Yep. Sir, formula lekuda sol chaikema. Vijay Reddy, formula lekuda idi session chusu. Where is that? Our formula revision class. Check this. Formula revision session chustava. Check this out. This session, right? The entire formula session with the PDF. Check this out. You will understand it. Okay? Cool? Let's move on. Let's move on. Next, Wien's displacement concept. Wien's displacement concept. Yes. Where if you increase the temperature of a body, the colors which come out of that body change. So if you increase the temperature, the wavelength of the color which is emitted decreases. That is your Wien's displacement law. There is a particular color which is radiated the most, that is called as lambda max. That is called as lambda max into the temperature is going to be a constant. Is going to be a constant. In fact, the graph part of it looks like this. This is lambda. This is intensity. So for a lower temperature, let's say the graph is like this. Let's say the graph is like this. When you increase the temperature, when you make it hot, then the graph goes like this. So lambda decreases for a higher temperature. This is high temperature. This is low temperature. That is how the graph is. This is Wien's displacement law. Yes. Kirtana, yes. Telugu, little bit Telsu. Yeah. Moving on to the next one. 3 stars A, B, C have surface temperature TA, TB, TC. A appears bluish, B appears reddish, C appears yellowish. What can you conclude? Come on, think about it. Bluish means the wavelength is the least. B appears reddish, that means the wavelength is the most. C appears yellowish, that means the wavelength is medium. So accordingly think whose temperature will be more, whose temperature will be less, because we all know temperature multiplied by lambda max is basically constant. The one which has more lambda has less temperature. So B has most wavelength, so it has the least temperature. So B should be least. So there is only one option like that. You can directly mark option number D for doctor. D for doctor. Yes. Okay. I hope this is clear. I hope this is clear. Rachel, my dear student, okay, let me tell you, first of all, you will also have to practice. Don't just say such things. Sir, I will just attend this session and I'll go to the NEET exam. You need to practice, bacha. You cannot just say, sir, if I watch this video of this doctor performing surgery, he is the best doctor in the world. He taught the surgery to be done in the best possible way. Sir, can I, operate? There is one person who is suffering from some disease. I will operate on him and will he be cured? I think he will be cured permanently then. So, always practice. Always practice after the class. Whatever models I give, practice more models. Practice more questions on the same formula, concept and models. Understood? Clear? Yeah. Very good. Awesome. Let's move on. Next question. Black body is at some temperature. The energy radiation emitted by the body at some wavelength is this one. And 500 wavelength is this much. Okay. And 1000 nanometer is at U3. So which of the following is correct? Which of the following is correct? This is very straightforward, my dear warriors. This is very, very straightforward, my dear warriors. Think about it again. Lambda into T is basically a constant and the energy radiated is directly proportional to T raised to 4. Is directly proportional to T raised to 4. So the one which has lot of wavelength will have less temperature. The one which has less temperature will have less energy. So out of this, who has the most wavelength? 1000, 250 and 500. So I think this has the most wavelength. So this will be the least. This will be the least. Who has the least wavelength? This one. So this will be the most highest wavelength. Highest energy, my bad. So U1 should be more than U2, which should be more than basically your U3. Exactly. So that is how it is. I think the answer marked here is wrong. Ignore it. So yes, U1 should be more than U2 and U2 should be more than U3. Yes, U1 should be more than U2 should be more than U3. Is that clear, my dear warriors? Yes. Everybody with me? Very good. Very good. Moving on to the next concept, that is conduction in rods. You take a rod and you heat one side and cool one side. The heat will go from the hotter side to the colder side. So this is our rod. This is our rod. And let's say you are having a length L, area of cross section is A. This is hot side. This is cold side. The heat will flow through it like this. The heat flow rate will be dq by dt, which is also called as the heat current. Heat current. And this will be nothing but K A delta T, which is hot temperature minus cold temperature. So T hot minus T cold divided by the length of it, Ka by L. Right. So that is the formula, my dear warriors. Now this Th minus Tc is also temperature difference. Temperature difference. You can relate this to a resistor. You can relate this to a resistor like this, where there is a voltage difference V, and there is a current passing through it, which is I. And we all know V is equal to I into R. So voltage is current into whatever this term, when taken this side, will become the resistance. So actually a rod carrying some heat can be converted as a resistor problem. It also offers some resistance to the passage of heat. So the thermal resistance formula is L divided by Ka. Because if you take L over here, K will come below. Current into resistance is voltage difference. So that's it. So this is heat current into thermal resistance will give you temperature difference. So that is the equivalent in current electricity for conduction. Both these are equivalent. So you can convert this into this or this into this. Okay, keep this in mind. This is called thermal resistance, which is L by Ka. So your series parallel combination, theory is valid even here, whatever you use in current electricity. Okay, Observe this particular statement now. What does this say? There is a rod, thermal, it is in contact with some reservoirs, not servoirs. Reservoirs as in a large object which can hold a lot of heat and maintain its temperature. And it conducts heat Q in time t. The rod is melted and the material is formed into a rod of half the radius. What is the amount of heat conducted by the new rod when placed in the thermal contact with the reservoir? Okay. Yeah. Let's see. Kirtuga, I would say you should solve at least the last 5 years. Recommended is last 10 years. Yeah. Okay. Okay. No worry, Caro, but this is a easy kill concept. That's the reason why we do it. Okay. So it's a very simple, like you can see, dq by dt, which is the heat current, dq by dt, which is the heat current, is K into A into basically delta T by your L. I will not leave the formula like this because radius is mentioned, length is not mentioned. I need to get rid of length. So I'll do one thing. I know that the volume is going to be constant when I melt it. It's clearly mentioned that the rod is melted. So volume will be constant. So area into length will be constant. So length will be volume divided by area. So when I substitute that, there will be volume here, area over here, this area as it is into delta T. A into A is A square, but area is pi r square. So pi r square whole square delta T. So this will essentially turn out to be dq by dt is directly proportional to the fourth power of r, So if that is the scenario, think about it. It is clearly mentioned the radius is halved. So if the radius is made half times, so 1 by 2 raised to 4 will be 1 by 16 times. So the heat flow rate will also be made 16 times less. So that is option B for your Baswa Sir biology. Yep, correct. Yeah, so Shri, that is the reason why you should watch this session. If your problem is applying formulas, watch this session and my older sessions. And next few days on this channel, I am going to only do problem solving. So all those students who suffer in problem solving will see your sir, physics teacher, solving all the problems and applying the concepts. When you see me apply the concepts, you will get the confidence, and in the exam, you will be able to solve a similar question. That is the reason I will have mainly problem solving classes in the next few days to come. Because if you revise the theory again and again, it is of no use. Okay? Keep this in mind. Next, the concept of beats. The concept of beats. When you have two sources of sound of similar frequency, maybe this is emitting some sound like this, this is emitting some sound like this, almost same. What you end up hearing is a loud sound, and then no sound. Again a loud sound and then no sound. Again a loud sound and then no sound. So this is what is going to happen. This is the phenomena of beats, from no sound to no sound, or from basically one loud sound to another loud sound, is called as the beat period, and we also have the term beat frequency, usually denoted by delta f, beat frequency, which is 1 by your beat period, and it comes out as the larger frequency minus smaller frequency. So f1 minus f2, I'll put a mod because I do not know who is going to be higher, who is going to be lower. That is your beat frequency. Also bear this in mind, whenever you have a tuning fork and you load some wax onto it, then the frequency reduces. When you load wax onto the tuning fork. This concept is also used for solving many questions. Is that okay, everyone? Awesome. Very good. Let's move on to some questions coming up on your screen. Here it is. In a guitar, two strings are made of same material and they are slightly out of tune. This was asked in NEET 2020. They produce a beat of 6. Tension in B is decreased, beat frequency increases. If A's frequency is 530, what is the original frequency of B? A frequency is 530. So A's frequency is fixed, that is 530. Now the problem is with the frequency of B. So B can have two possibilities. B can have two possibilities. One is plus 6. So it can become basically 536 because beat frequency is 6 Hertz. So the difference is 6. Second possibility is it is minus 6. So B's frequency can be 524. Can be 524. These are the two possibilities. Now look at the question. When tension in B is slightly decreased, what happens when tension changes? Well, velocity is root of tension by mu. If tension is decreased, speed of sound will decrease. If speed of sound decreases, frequency of the string, remember it is NV by 2L. Speed decreases, frequency also decreases, which means what has happened? When you reduce the tension in B, B's frequency also decreases. So 524 might become 523. Example, it might become 523. 536 might become 535. If that is the scenario, then what is the gap? What is the beat frequency in this case? 530 and 535, that is 5 Hertz. That is basically 5 Hertz. And in this case, well, it is 7 Hertz. So which possibility will you choose? Which possibility will you choose? It is clearly mentioned. It increases to 7 Hertz. So the gap has widened. That means this is the possibility which you will take. So the actual original frequency will be 524 Hertz. That's how you solve the question. That's how you solve the question. Understood, my dear warriors? Pakka? Everybody with me? Great, great, great. Perfecto, perfecto. Let's move on to the next question coming up on your screen. Wave speed on a string and sound, right? So few things which you should know. For a wave speed on a string, use this formula, root of tension by mu. This is mass per unit length, which can be also written down as density into area of cross section. This is for transverse wave on a string. Transverse wave on a string. Very, very important formula. Then the next formula is for speed of sound. Speed of sound in a solid, this is longitudinal wave, is given by root of Young's modulus by density. Speed of sound in liquid is given by root of bulk modulus by density. Speed of sound in gas is given by root of gamma p by density, which is also gamma times gas constant temperature divided by m. That is also okay. That is also okay. Very good. Also keep this in mind. The wave equation is generally looking like this: a sine kx plus minus omega t. This is how the wave equation looks like. If it is plus, then understand it is going along the negative side. If it is minus, then it is going on the positive side. Then it is going on the positive side of the x-axis. Also keep in mind the wave speed is given by omega by k. If you want to look at the wave speed using the equation, divide this omega by k. What is omega? It is nothing but 2 pi f, which is also 2 pi by the time period. What is k? Angular wave number. It is 2 pi divided by lambda. What is a? It is nothing but your amplitude. It is nothing but your amplitude. So this is the formula that you will remember for solving any wave speed questions. Correct. I hope this is clear. Yep. Yep. Right? Shall we do this? Shall we do this? All right. Let's do the questions on this. If the initial tension on a string is doubled, then the ratio of the initial and the final speeds of the transverse wave. I want everybody to put up the answer in the chat box. Come on, everybody, Chependi. Everybody Solanga in the chat box. Bega bega answer Kodi. Come on, everyone. Ridhashri Ames, I think this was also made for chemistry. If you remember yesterday, Diksha ma'am has done this, if I'm not wrong. Yeah. Sure shot theory plus questions. Yeah, this is mainly for students who want to score at least 80 marks or, you know, bare minimum cutoffs, you know, in your chemistry. So this is that session. So watch this. Okay. Right. Great. So what do you think, guys? Option D, Pakka? Right, right. Come on, come on. Kumar GP says 4. Susmita says 4. Sushi Mama says 4. Oh, Karo, you are the Champa. Why God. Champa and Pandu, I want to meet both of you very, very soon after the NEET exam. I met a lot of Pandus and Champas in the Chennai Center recently. It was amazing fun. So if the final tension on the string is doubled, what will happen? Guys, initial speed is root of tension by mu. Final speed, the tension is doubled, right? So 2T by mu. So basically take the ratio V1 by V2. Mu will cancel. Root T by 2T. So basically it will be 1 by root 2. 1 by root 2. Yes, direct answer. Direct answer. Very nice. Let's move on to the next one. Now here lot of geometries are there and you will have to find the fields because of that. So you should know all the standard formulas, like for a point charge. For a point charge at some distance, what is the field, what is the potential? What is the field, what is the potential? Then for a shell, at outside as well as inside, what is the field, what is the potential? Then for solid sphere, that means, you know, it is charged completely. What is the field? What is the potential? Then for a ring, what is the field? What is the potential? Right? Then also for a line charge distribution, only know what is the field formula. And obviously for a sheet, if it is charged, then what is the field formula, which is sigma by 2 epsilon naught and all of that. Also inside the conductor, the field is 0 and outside the field is perpendicular and it is given by sigma by epsilon naught. All these basic things you should know, and everywhere here potential is constant. Potential is constant. So all these basic things you should know, and obviously Coulomb's law between two charges. So what is the force between the two charges, which is K Q1 Q2 divided by R square, and energy is K Q1 Q2 divided by R. Same thing for gravitation also. All these things I have covered in the formula revision class. Please mug up, revise, write it down 10 to 30 times so that you remember all these formulas. So some questions which can be asked in electrostatics. Again, a sure shot concept for your NEET physics 2024. A sphere is given a positive charge, whereas another sphere is given exactly of same mass and equal amount of negative charge. So what do you think will happen? Mass of A and B will remain equal. A will increase, B will decrease, mass of B increases. Simple this is, because it is clearly mentioned that the mass is same, but it is given negative charge. Negative charge means electrons, and electrons carry mass. So the moment you give electrons, what will happen? The body will have more mass of the electrons, so the body's mass will increase. So mass of B will increase. That is what the correct answer should be. That is what the correct answer should be. Everybody understood this? Because electrons have masses. If you give positive charge, you have taken out electrons. So you have taken out some mass. Understand that. So A's mass will be slightly less, B's mass will be slightly more. Very good, Kirtana. Very good, Jata, Kumaropi, Kaushal. Awesome, awesome. Yes, world of Mr. Motivator. This is more than enough. More than enough. These topics. Practice the questions from these topics. So my dear students, next question coming up on your screen. 2 point charges A and B having charges Q and minus Q are placed at certain distance apart. Force acting between them is F. 25% of the charge is transferred to B. Then what is the new force between them? That is the question. Question on Coulomb's law. How to solve these model of questions? Let's try to solve this, my dear warriors. A and B are given. The distance between them is fixed and there is some force between them. The charges are Q and minus Q. Q and basically minus Q. Force, oops, sorry, it will not be repulsive, it will be attractive, my bad. Yeah, the force will be basically attractive in nature, and that force will be K, Q, Q divided by R square. Now what are you doing? Same distance, but 25% of A charge is given to B. 25% of A's charge is given, that means how much is remaining? 75%. So what is 75%? 3 by 4Q. And you give it to this guy. Think about it. What has happened? You removed Q by 4 from this. You removed Q by 4 from this. And here you have added Q by 4. If you add minus 1 to plus 1 by 4, it will become minus 3 by 4. So this will become minus 3Q by 4. Understood? I have removed 25% and added 25% over here. So minus Q plus Q by 4 is minus Q by 3Q by 4. So what is the new force between them? What is the new force between them? It will be K into 3Q by 4 into 3Q by 4 divided by R square. 3 by 4 will become 9 by 16 KQQ divided by R square. KQQ by R square is F. So it will be 9 by 16 times of F. 9 by 16 times of F is option number C. Very good. Excellent. Awesomeness. Moving on. Next question. Hollow metallic sphere is uniformly charged. The field due to the sphere at a distance r from the center. So, like I told you, you should know all the geometries like I mentioned over here. All the geometries. This is a question on this particular geometry. If you remember the formula, it will be very, very easy. Let me remind you, how does it look? If you take a uniformly, it is a hollow metal sphere. It is a hollow metal sphere, means basically it is a shell. It is basically a shell. So, if you are outside, then the field is given by KQ by small r square. Whereas, if you are anywhere inside, then the field is just 0. Field is basically just 0. Right. A hollow metallic sphere. Hollow means it's a shell. So, which is the most correct option, my dear warriors? Which is the most correct option, my dear warriors? 0, I think, for r less than r and decreases as it moves away. Yes, that is the most correct answer, because if you draw the graph also, it will look like that. Electric field versus distance. It will be 0 inside, and then after you go out, it will go inversely proportional to r square. Inversely proportional to r square. Yes, option number B, not C. Option C says increases. It is not increasing because r is in the denominator. Remember, it will decrease. B for Baswa sir. Correct. Guys, have you smashed the like button or not yet? Or you're chumma attending the class, sir, free class, sir is there, okay, fine. What does it matter? Anyways, sir is going to be there only for the next 10 days. After that, where we'll meet sir? You should have that sense of responsibility. You are going to become doctors. You have to give that Guru Dakshina. And that Guru Dakshina is nothing but that like button. Because only when you give the Guru Dakshina, whatever knowledge you gain from any teacher, not just me, any teacher, that will sit in your head and it will be actually useful when you need it the most. That is your exam in this case. Or else it will just go off. You should always, be thankful wherever you learn. Even if your friend teaches you something, even if some unknown person teaches you something, any YouTube teacher, offline teacher, online teacher, be very thankful because they will play a very important role. Okay, and I'm hoping that you will do really, really well if you practice all these questions and you get those bare minimum marks and hopefully the better college which you would probably deserve, right, in the last few days, otherwise which you would not have got. Imagine losing out on a college because of physics or chemistry or any even biology. That would hurt you. And that is the reason why I've come here to give you that hope, to give you those questions, those models, right, for the bare minimum marks. Coming up on your screen, the next one, potential due to different geometries. Same thing, all the potentials also you should remember whatever I told you over here. In this particular slide I mentioned you. It's also not just the fields but also the potential values for different geometries that you should remember. So let's solve some questions, guys. Where does it go? Yes, here. Yeah, come on. Thank you, Sagurti Kirti. Thank you so much. Yes, Caro. Thank you for the support from Champa. Yes. No, definitely the knowledge will be useful, Sagurti. Okay, yeah. So what do you think is the answer for this? 27 drops, same size, are charged to 220 volts each, and they are combined together. To form a bigger drop. Calculate the potential of the bigger drop. So when the drops combine, their volumes will add. So 27 drops, each of volume 4 by 3 pi r cube, will become a big drop of volume 4 by 3 pi capital R cube. 4 by 3 pi cancels. 27 is basically 3 cube. So 3 cube R cube is capital R cube. So R is basically 3 times of R. Now the next concept is potential. See guys, the potential is given by the formula K cube by radius. So 220 is basically K cube by R. Now for the new one, for the new drop, the bigger drop, the potential is unknown. In fact, I can write it as KQ by capital R, which is 3 times of R, which is basically 3 times of R, right? Yes. Calculate the potential of the bigger drop. Now, a lot of people forget this part, that when you add all those spheres, even the charges will get added up. So, technically, it is not just KQ by R. Understand, the big drop has a charge of 27 times of Q. Yes, and this divided by R. Lot of people forget that, because 27 drops, each charge Q will become 27Q. So the charge on it will be 27Q. So this will become K into Q into 27, and this is basically 3R. So 27 by 3 is 9. So 9KQ by R. Sorry, correct. So 9 into KQ by R. What is KQ by R? It is 220. So it is 220. What is 220 into 9? That's going to be 1980. Yes, 1980 is the answer. Correct. Perfect. 1980. Option A. Got it, my dear warriors? Yep. Sir, is PYQ in-text mock test enough for 160 to 170? No, Sri Lanka land, 160 to 170 marks. That is not enough. You need to practice more. I mean, in fact, even those questions you should have practiced at least 2 times. In-text questions, PYQ questions, NCERT back exercise questions, right? And your coaching module. At least 2 times, 1 to 2 times if you have practiced, then you can expect 160 plus or close to 170 marks. Cool. Let's move on to the next one. There is a certain region where the potential is found to be 5 volts throughout the magnitude of the field in the region. This is such a simple question. I want everybody to spam the answer. Come on, my dear students. Magnitude of the field. It's clearly mentioned the potential is found to be 5 volts throughout. So potential is constant. And remember, field always goes from high voltage to low voltage. When there is no change in the voltage, where will the field go? Nowhere. So field is not going. That means the field is going to be a big fat 0. Yes, that's the answer. Option C. Nope. It is not B. It is C. Yes, Lekha. Very good. Yes, Kuklate, it will be conducted UGW on the JE channel. Awesome. Thank you, Krishna, for all the support from all the little minions, Pandus and Champas. Thank you so much. Moving on to the next question, guys, coming up on your screen. Yes, electric dipole. Electric dipole, also very important concept, where you have a dipole. This is positive, this is negative. Dipole moment is charge into length, and you will see that the field on the axis is given by 2kp by r cube, and the field on the equator, is given by just kp by r cube. This is the axis and this is the equator. Also the potential over here or here the potential is 0, or here the potential is 0, and in general if you want to find the potential, it is basically Kp cos theta by r square. That is the formula. Theta is the angle made with the axis. Theta is the angle made with the axis. So you should know the field and the potential formula for dipoles. You should also know what will happen if you place a dipole in a field. If you place electric dipole or magnetic dipole in somebody else's electric field making angle theta, then there is a torque acting on it, and the torque is Pe sine theta, and the potential energy is minus Pe cos theta. Basically there is a dot product here and there is a cross product here. Sine means cross, dot means cos, right? So that is the torque acting on the dipole which aligns it in the direction of the field. It also has some potential energy which is given by negative Pe cos theta. So these are the formulas which will be useful there. And what do you think? Oh, by the way, in these cases also keep in mind one more thing. The net force acting on the dipole is always going to be 0. The net force acting on the dipole will be always 0 if it is kept in a uniform field. Okay. So polar molecules are the molecules having complete theoretical question. These kind of questions can come. What do you think? Polar molecule is what kind of molecule? Polar molecule is what kind of molecule? Sri Lekha Land, I am making a mock test for 160, 170. That is called as a trickiest mock test. And in fact, there will be a mock test containing aims and other papers also, where we are solving all those difficult questions. So that is coming up in the coming few days. So hold on for that. Okay. Yes, it is coming up. All right. Come on. What do you think? Heart Hacker saying B. Sagruti also saying B. Jalak also saying B. Interesting. Very nice. Everybody made a mistake. It is having a permanent electric dipole moment. Guys, polar molecule like, you know, H2O. H2O. It's a polar molecule, right? There is delta 2 negative. There is delta positive charge on the hydrogen. So it is having a permanent dipole moment. It acquires in the presence of electric field? No. Then it is getting polarized in external field. It is not. It is, then those charges are induced charges. No. It will always have polarities even when nothing is present around it. That is the meaning of polar molecule. So guys, be very careful. It is not B. Everybody said B because one person said B. Actor Rohit said D. Kaushal said D. Yes. Very good. Excellent. Excellent. And guys, as we are speaking, I hope you have subscribed to the Vedantu NEET English channel, or else you will miss out on a lot of things. And by the way, we are going to discuss the final NEET paper also on this channel. And let me tell you, the team is working really hard, and there are a lot of amazing sessions to boost your score by, you know, a lot of marks. If you are at 400, 500. If you are at 500, 600. If you are at 600, taking you to 650. If you are at 650, taking you to 700. So all these kind of sessions have been planned in the next week. Make sure you are attending every session on the #1 NEET English channel in the country for all the students, and the #1 NEET channel for all the students in South India. So make sure you are subscribed, and also talk about this channel to all your friends. Dipole is in the electric field. Positive, negative charge is there. So come on guys, where do you think it will move? What direction do you think it will move? Yep, come on, think and tell me. See, here a lot of people will say, sir, net force is 0. Because sir, right now only you told that the net force acting on a dipole is going to be 0. But be little bit careful, my dear warriors. That was only true for uniform field. This field is non-uniform. Here the field lines are far, so it is a weak field over here. Here the field lines are close, so it is a strong field over here. So what do you think will happen? Yes. What do you think will happen? Come on. Oh, I think on another channel. there is my session which is pending. Yeah. Guys, I'll have to shift the UGEE class to some other time. I will be taking the UGEE class. Don't worry, later on. Yeah. Don't worry, I'll be taking it. Yeah. Yes. So the strong field will apply a strong force like this, and the weak field will apply a weak force like this. So the net force will be in this direction. So definitely towards the right as the potential energy will decrease. Yes, it is going to be towards the right side. Towards the right side, correct. Vaishnavi Reddy, I'll be taking it today only, but at some other time. I think there was a clash somehow. Probably they did not change the time. I will definitely conduct the class today. Don't worry. Next one. Gauss law concept. Again, very, very important concept, my dear students, where you will see that if you have a closed surface and there are some charges inside, and these charges will create field lines around it, there might be also some charges which are placed outside. Only worry about those charges which are placed inside, and if you measure the total charge which is inside and divided by epsilon naught, you will see that whatever electric flux will be cutting through the surface, whatever electric flux will be cutting through the entire surface will be this value. So the total electric flux will be E vector dot dA vector. Total flux means integration, closed surface means cyclic integral. So this is your total electric flux, for the closed surface. It is inside charge by epsilon naught. Whatever charge is enclosed inside divided by epsilon naught. The placement of the charges really don't matter. Exactly. The placement of the charges don't really matter. So let's see if you guys can solve this. A sphere encloses an electric dipole moment with, electric dipole with charges 3 into 10 to the power minus 6 plus minus. What is the total flux across the sphere? So there is a dipole, there is a positive charge and a negative charge. And now I take a sphere which contains both of them. If I ask you what is the total charge which is inside, the answer will be 0. So this divided by epsilon naught will also be 0. So the total flux should also be a big fat 0. That is according to Gauss's law. So the answer is a big fat 0. That is the answer. Yes, option C. Correct. Awesome. Awesome. Let's move to the next question, right? Everybody, let's move to the next question. This is another question. This was asked in NEET 2021. The flux through the cube side, if a charge is at one of its corner. Very nice question. Imagine there is a cube. Imagine there is a cube, something like this, and a charge is placed at one of its corner. Maybe the charge is present over here. And you have to find the flux through the side of a cube. That means through, let's say, this side, example. That means through this side, for example. To do that, visualize more cubes around it. Visualize more and more cubes around it. So something like this. I'll just draw it for your sake so that you are able to visualize it. See if you are able to visualize it, and even more cubes on the top. See if you are able to visualize this. Are you able to visualize this? Basically, there are a lot of cubes over here. How many cubes are there? Totally 8 cubes are there. Can you see? Totally 8 cubes are there. Everybody? Total, it is 8 cubes. How? 1, 2, 3, 4 below, 1, 2, 3, 4 on the top. So now the electric flux will go on the top, will go on the bottom, will go on this side, will go on this side, will come in the front, will go at the back. So 6 ways it will get distributed. So flux through any one face, any one big face, how much will it be? It will be Q by epsilon naught into 1 by 6, because it is getting distributed in the 6 directions: up, bottom, front, back, left, right. So on any one face the flux is this much. So on this shaded part, how much flux will be there? It will be 1/4 of it, because any face that you consider, my dear warriors, has 4 parts. I hope you can see that. 1, 2, 3 and 4. So 4 parts are there. So 1/4 of that. So it will be 1/4 of this Q by epsilon naught into 1 by 6. 6 4s are 24. So Q by 24 epsilon naught. Q by 24, I think something is wrong. What is the flux to a cube of side A if the point charge? I think the answer mentioned over here is wrong. One of its corner. Offside. What is the flux through a cube? Oh, sorry. Through the entire cube they have asked, not through a side of that. The side length is A, my bad. Through that entire cube, yes, it will be 1/8. In fact, what you could have also done, probably I'll show it to you on the next slide itself. My bad. Something like this, let's say, and you add one more over it. Yes, I think this should be fine. And now imagine the charge to be at the center. There are 8 cubes, right? So through any one of the cube, 1/8 of the total flux will go. 1/8 of the total flux will go, because there are 8 cubes. Think about it that way, that through each cube some flux will be going. So there are 8 such cubes. So 1/8 of the total flux will go. So therefore the answer should be 1/8 by Q by into Q by epsilon naught. Is that okay? That's what the answer should be. Correct. Yep. Entire cube. Yes. So if it is the entire cube, it will be 1/8. If it is from the face of the cube, then it will be Q by 24 epsilon naught, assuming the charge is at the corner. Okay. Let's move ahead. Kirchhoff's voltage law, Kirchhoff's current law, and the circuit. Kirchhoff's voltage law, completely based on conservation of energy, and the total sum of the voltages across a loop is 0. That is your Kirchhoff's voltage law. Kirchhoff's current law, completely based on conservation of charges, and it is nothing but total current flowing in is the total current which is flowing out. In case of circuits, you should know both how to deal with series, parallel, Wheatstone's bridge, right? And some, special forms. What are those special forms? Like this one. There is a resistor here, there is a resistor here, there is a resistor here. You do this. This is basically all the 3 resistors are in parallel. R1, R2, R3, all the 3 are going to be in parallel. Then another special form is this. One resistor here, and another resistor here, another resistor here, another resistor here, another resistor here, and another resistor here. You can disconnect this. You can basically disconnect this and separate it out. This problem is also very, very famous. Please solve it. Okay. And also the third kind of problem, which is basically an infinite ladder problem. Infinite ladder problem. Resistors are there one after the other and connected like this, okay, infinity. These three questions are very, very important. Question number 1, question number 2, question number 3. These are your special forms apart from Wheatstone, series and parallel. Just have a look at it. You can see my old classes also. Kirchhoff's law says that sigma I is equal to 0 at a junction is based on the law of conservation of what? Is based on the law of conservation of what? Yes. No, it was not series, Shruti, that previous one was parallel, okay? So yes, it is based on the law of conservation of sigma I. It is Kirchhoff's current law, so it is based on law of conservation of charge, yes. If it was sigma V is 0, then it will be law of conservation of energy, because that will be Kirchhoff's voltage law. This is Kirchhoff's current law. Total current is 0. If you count total current in and total current out, net will be 0. Nothing will be remaining. No charge will be, residue. Next one, coming up on your screen, there is a circuit given and the question is basically, find the ratio of the currents I3 by I1. I3 by I1, that is the question. Let's see how do we solve this particular question. This is using Kirchhoff's law. This is again common type of question. This was asked also previously. So first of all, R2 and R3 are in parallel. R2 is parallel to R3. So therefore, the voltage across 2 should be voltage across 3, right? In parallel, what is same? Voltage is same, currents are distributed. In series, current is same, voltage is distributed. So voltage is current into resistance. So I2 R2 will be I3 R3. I2 R2 will be I3 R3. Everybody fine till this point? Okay. Next, I know one more thing. I want to find I3 by I1, right? Okay. So I2 by I3 from here, shift I3 below, will be R3 divided by R2. Now there is a property called as componendo, where you add the denominator to the numerator on both sides, the ratio remains the same. So I can do one thing, I can write it as I2 plus I3 divided by I3 will be R3 plus R2 divided by R2. This is using the componendo property in basic maths, chapter 1. What is I2 plus I3? This is using Kirchhoff's law. Observe carefully over here. Current I1 is going here, I2 is going here, I3 is going here. I2 plus I3 should be I1. So I2 plus I3 is nothing but I1 using Kirchhoff's law. So I1 by I3 is R3 plus R2 divided by R2. Question is I3 by I1. So I3 by I1 will be R2 divided by R2 plus R3. So R2 by R2 plus R3, where is it? Option number 4. How many of you said option number 4? D. Very good, Meghna. Proud of all of you. Awesome. Awesome. Very good. Very nice. Yeah, the PDF will be provided after the class. Don't worry about it. Yes, the PDF will be provided after the class. Definitely. Okay? Okay. Perfect. Perfect. Let's move on to the next question coming up on your screen. Let's hurry up. A lot of things we have to do, guys. As much as possible we'll do, and all the remaining topics and question models I'll give it to you in the PDF form also. Don't worry about it. Yes, the circuit given below, Kirchhoff's rule says that BCDEB is given by, okay, Kirchhoff's loop rule for BCDEB. BCDEB. Okay. So when you have to apply Kirchhoff's law, what do? Sum of the voltages is 0. Start from B. When I go through B, I encounter resistance R2. So voltage difference across resistance R2 is how much? Think about it. Voltage difference across resistor R2, then voltage difference across EMF E2, then voltage difference across EMF E3, then voltage difference across resistance R1, and I come back to the same point. That is equal to 0. So across R2, I am going in the direction of the current. So current goes from high to low high to low is a downside, so it will be negative minus I to R2. Ohm's law, V is IR, and negative because it is going down. Battery positive to battery negative, positive to negative, down, so it is minus E2. Then here, negative to positive, it is a jump up, so plus E3. Then over here, I am going to be opposite to the current. Current goes from high to low, but I am going from low to high. Low to high is a jump, so plus, and current is I3, resistance is R1, so that should be the final answer. Okay, minus I to R2, is it there? Minus I to R2 minus E2 minus R2 R2. Oh, multiply this with minus 1, so you will get I to R2 plus E2 minus E3 minus I3 R1 is 0. Where is it? Yes, it is there as option number B, 2. Yes, you can see that right over here. Option number 2 is the correct answer. Thank you, Tech. Thankfully, I am not your dance teacher. Or else, if I will be your dance teacher, means you will definitely find roles as props or side dancers in a Rajnikant movie or Allu Arjun movie. Yeah. Or some very side roles you will find if I become your dance teacher. Thankfully, I am not your dance teacher. But some students also said that, sir, someday you should act in Telugu or Tamil movie, sir. I am considering that after I retire from teaching. Okay? Not now. Very soon. And I told them also, I can't dance so well, so how do you expect me to be a good actor in Telugu movie or Tamil movie? So then the students are like, sir, many people don't know, sir. Yeah. Even Vijay Thalapathy didn't know good dance, but he learnt. Maybe someday. Voltmeter, ammeter based questions. Voltmeter, ammeter based questions. Yep. Right. So how do you solve these kind of questions? Voltmeter, ammeter. For voltmeter, remember that your galvanometer is connected in series with another resistance. This becomes your voltmeter. This has very high resistance, and that device is connected in parallel with whatever circuit or device that you want to measure the voltage across it. That is your voltmeter. Okay, so that's your voltmeter. And it so happens that if you want to measure the voltage, and let's say the voltage is V, that voltage is whatever current will flow obviously here through the galvanometer. So Ig into total resistance, which is Rg plus Rs. Okay, the voltage measured across the device will be also the same because both of them are in parallel. Similarly, for ammeter, what do? You take the galvanometer, right, and connect a shunt resistance across it. It's called Rs, but naming is different. Here S stands for shunt, here S stands for series, so be careful about it. This device is obviously your ammeter, and it has very low resistance. Yep. And this is connected in series across the device where you want to measure the current. And the actual current that you are measuring could be I over here, but the current which is going through the galvanometer, could be probably Ig, something like this. So this is how the circuit diagram looks like for your ammeter. Correct. And then you will say basically Ig, Rg will be I minus Ig, I minus Ig, because that's the current which will go from here, I minus Ig into basically Rs. This is the equation that you will be using for ammeter. Why is this true? Because voltage across, this is since voltage across galvanometer is the voltage across shunt resistance. Voltage is IR, that's all. So that is the equation for ammeter, that is the equation for voltmeter. That's it, ammeter, voltmeter equations. Simple, easy peasy. Let's move on to the questions coming up on your screen. Oops, I showed the answer anyways. So galvanometer of some resistance, full scale deflection 100 milliamperes has to be converted into an ammeter of 1 ampere range. The shunt resistance should be how much? So quickly let's see. 90 ohm galvanometer, 90 ohm, and you can maximum allow how much? 100 milliamperes through it. 100 milliamperes through it, which is basically 0.1 ampere, not more than that. So you will obviously connect it with a shunt resistance. You will connect it with a shunt resistance of unknown resistance like this. Okay, perfect. And how much current enters in? 1 ampere current enters in. 1 ampere current enters in. 0.1 goes here. How much will go here? 1 minus 0.1, which is 0.9 amperes. Now the voltage is same across both of them. The voltage is same across both of them. So voltage across galvanometer is voltage across the shunt. Voltage across galvanometer is I into R, which is 90. Voltage across shunt is I, which is 0.9 into R. Yes. So what do you think this will become? 0.9, 0.199 cancels. So Rs will just become 10 ohms. Yes, that should be the answer. That should be the answer, 10 ohms. Very simple questions are there on these voltmeter and galvanometer and ammeter. Cool? Thank you, Tech. Yeah, maybe someday like Mahesh Babu. Mahesh Babu is also one of my favorite. Not like Allu Arjun. Allu Arjun role I will not get. I tried. I had called Rajmouli sir. Like, no, you will get Mahesh Babu roles. I said, okay, fine. I'll come after a few years. Galvanometer of resistance 100 ohm full scale deflection at 30 milliamperes has to be converted into a voltmeter of range 30 volts. The series resistance is, come on. How many of you Mahesh Babu fans? How many of you Allu Arjun fans? What do you think is the answer for this? Galvanometer of resistance 100 ohms full scale deflection is 30 milliamperes has to be converted into voltmeter of 30 volts. So remember, for voltmeter you have to convert you have to attach a series resistance. The galvanometer resistance is 100 ohms. Series resistance, don't know. Maximum current which can flow 30 milliamperes. That is your voltmeter, and you connect it across a device and you end up measuring the voltage of 30 volts. Right. So this voltage is the total current into the net resistance. So 30 volts is current, which is 30 milliamperes, into the resistance, which is 100 plus Rs. Got it? 30 cancels. So it will become basically 1000 is equal to 100 plus Rs. So Rs is basically 900 ohms. Yes, that is the correct answer. Wow, very good. Thank you, Divya. Thank you so much. We'll be waiting. I'm so happy. I hope you guys find time when you enter into colleges. Yeah, but I'm so glad. Okay, chalo. Let's move on to the next one, resistance, current, drift parameters. Yeah, so basically questions like this. Resistance is rho into L by A, resistivity into length by area. Resistance at temperature T is original resistance 1 plus alpha delta T. Then another type of question, current is number of charges per unit volume into drift speed into electron charge into A. which is the area of cross section. Also, you can shift area below, so it will become J is equal to current by A, current per unit area, which is NVDE. You will also see equations like for drift speed, where drift speed is equal to E by M into your relaxation time. Then also equations like V is equal to IR, and instead of voltage per unit length is field, current per unit area is current density, resistance of unit volume unit length is resistivity. You can also write this as J by sigma. This was resistivity, this was conductivity. This is also okay. Also, you will notice mobility formula. Mobility formula, what is it? Mobility formula is the drift speed per unit electric field. All these formulas you must know, as simple as that. Okay, all these formulas you must know, which are basically current parameters of circuits. Like for the example, this one, a copper wire of some length, some radius has electrical resistance. The density in the wire for the electric field to be this much is how much? Come on, let's see. Everybody try to figure this question out. What do you think the answer should be? What do you think the answer should be? The length is given, the radius is given, resistance is given, field is also given, the current density is asked. So because the current density is asked, I think E is equal to rho J. That is the equation we should use, I feel, because resistivity can be found, field is given, field strength is 10, resistivity I don't know, but how do I find it? R is equal to rho L by A. So rho is RA by L and resistance is 10, area pi r square. So pi into r square, radius is 10 raised to minus 2 by root pi whole square by length is 10. 10 cancels, pi cancels, it will become 10 to the power minus 4. Bring that 10 to the power minus 4 here. J is as it is. So J is 10 to the power 5 amperes per meter square. Is it option A? Yes, it is. Wow, such a easy question, direct based on formulas. These are the kind of questions you will get. Yep. Is that right? Everybody? Very nice. Very nice. Awesomeness. Very good. Moving on. Yep. Coming up to the next question on your screen. Across a metal conductor of non-uniform cross section, what is that thing which remains constant? Come on, think and tell me. Think and tell me. Meanwhile, let me just message Gopika ma'am and Basav sir. Yes. What is the answer, guys? I hope you have given the correct answer as B. Let me see. Oh, some people said 4. No. It is 2. Very good, Meghna Balu. Yes. Yes, Saguruti. Yes, the answer is 2. Why is the answer 2? Understand it. If the cross section is non-uniform, also, the current through this or this will be the same. All the charges will go through all the planes. Whether you take this plane or this plane, same charges will go. So the current will be the same. In fact, current density won't be the same because current density is current per area. So area is changing. Drift speed will also change because it has area in it. Also electric field will change because J will change. E is rho J. So if J changes, E will also change. So all the other quantities will change, but only the current won't change. Yes, that's the answer. Try to solve this particular question, my dear warriors. The question is basically, wire of certain resistance is stretched to twice the length. Most common pattern. Expect this kind of question in the NEET examination. Yes, come on. Yeah, so I'll be extending the class till 12:15, guys, and then you will have a break of 10-15 minutes before the next bio class. Yep, thank you, Krishna. Yes, you will have a break after that. All right, what do you think is the answer? The answer is 16 ohms. A lot of people make a mistake thinking, sir, resistance is rho L by A, sir. Sir, the wire is stretched to twice the length, sir. So length is increased 2 times, resistance will increase 2 times, 4 into 2 is 8 ohms, sir. That is not the correct answer. Be very careful because it is stretched. So volume will be constant. So area into length is constant. So area will be volume by length. So instead of area over here, put volume by length over here as it is. So it will be rho and L by area. Area is volume by length. So it will become basically resistance is rho L square by V. So resistance is directly proportional to the square of the length. So if the length has been made 2 times, square of 2 is basically 4 times. So 4 times will be the resistance. Original was 4. So 4 into 4 is 16 ohms. 4 into 4 is 16 ohms. Old resistance was 4. 4 4s are 16. Understood? Be careful when especially volume is constant. Yes, this is the catch. Many students make a mistake with. Next common type of question is this one. Force is charge into velocity into B and force is I into L into B. Lorentz force. Common question. And based on this you have applications of a charged particle which is thrown in a magnetic field and going in a circular path. The radius is given by mv by qb and the time period is 2 pi m divided by qb. These are standard formulas. You should also know that concept of, that helical path, helix. It goes in a helical path if it is thrown at an angle. Remember it, there is theta. So then the radius is mv sine theta by qb, and there is a term called as pitch, which is time period into horizontal velocity, which is v cos theta. The same time over here. These are the important formulas which you should know here. And another concept is of velocity selector, where a charged particle goes in a straight line even when there is electric field and there is magnetic field in that region. So that velocity is given by E by B. If it is not equal, it will get deflected. These concepts are again very important. In ILB, you should know that if you take a loop and place it in a magnetic field, uniform one, then the net force acting on it is 0. Net force acting on it is 0. Also, the loop has its own magnetic moment. Magnetic moment. Remember that the magnetic moment is number of turns into current into area. This is also a very, very important formula which you should know. And magnetic moment can experience torque and have energy. Those are same concepts which you have learned in electric dipole. These are main key concepts in this particular section. So a strong magnetic field is applied along the direction of the velocity of the electron. The electron will move along which path? The electron will move along which path? Come on. Yes. What do you think is the answer? A strong magnetic field is applied along the direction of the electron will move. If the magnetic field is applied in the motion of the electron along the velocity cross B will be 0, force will be 0, acceleration will be 0, velocity will be constant. So it will just go along the original path. Yes, it will just keep on going along the straight line. There is no need for it to turn. Understand that. Yes. If the answer was helical path, then the velocity will be at an angle to the magnetic field. If it is circular path, then the velocity will be perpendicular to the magnetic field. If it is parabolic, it can never happen with magnetic field. This can only happen with electric field. So if the charge is thrown like this and there is electric field, then it can be parabolic path. So for original path, you know, our answer will be this one. Okay, moving on to the next one. Hydrogen ionized atom and alpha particles of same momenta enter perpendicular to the magnetic field. The ratio of the radii RH by R alpha will be how much? RH by R alpha will be how much? That is the question. Come on, think about it. RH by R alpha. Ratio based questions are very common in your NEET examination. So all these questions, guaranteed questions for your 80 plus marks, bare minimum cutoffs for all of you to get a government college or a good private college. So ionized hydrogen atom and alpha particles, same momenta, perpendicular. Perpendicular means circular motion. The path radius. Radius is mv by qb. Mass into velocity is momentum. Same momenta is given. So p by qb. Since momentum is same, so radius is inversely proportional to charge. So RH by R alpha will be Q alpha by QH. So alpha charge will be plus 2e. Ionized hydrogen will be plus E. So it will be 2 by 1. So where is 2 by 1? Option number, or 1 by 2. Why is it saying 1 by 2? Did we make a mistake? RH by alpha. No, it should be 2:1 only. Same momenta, perpendicular, radius. Yes, it should be 2:1 only. 2:1. Hydrogen has 1 charge and alpha particle has double the charge. So it is 2:1. Yep. Very nice. No, it is not 4, Virati. Be careful. I think you made a mistake. 2:1. Yes, Susmita. Yes, Saguruti. Very good, my dear warriors. Everybody mark the answers, spam the answers quickly. Moving on to the next one. What is this? Magnetic field due to arc, loop, wire, solenoid and toroid. Yeah, quickly let me give you the formulas. For a straight wire carrying current, the magnetic field is given by mu naught I by 2 pi r, which is outside, and when you go inside, it is mu naught I small r divided by 2 pi r square when you are inside the wire. R is the radius of the wire. Radius of the wire. This is very important. Then you have magnetic field due to a loop carrying current loop carrying what do you say? Yeah, magnetic field due to a current carrying loop. So the magnetic field at the center is given by mu naught I by 2r, and if it is just an arc, and then you have to find the magnetic field due to it, then you just multiply mu naught I by 2r with theta by 2 pi due to an arc. For an arc, this is for a loop. And if you stand on the axis of the loop, if this is a loop and you are standing on the axis, then it is mu naught I divided by 2 r square plus x square whole raised to 3 by 2, and here you have r square. Similarly, you have for a solenoid. For a solenoid, the magnetic field inside is mu naught number of turns per unit length. This is number of turns per unit length into current, and when you are at the end, it is mu naught Ni by 2. This is at the end. Inside, it is almost uniform. Lastly, for a toroid, which is basically like this. So for a toroid, if the radius is r, the magnetic field is given by mu naught. Same thing, instead of n, you have number of turns per unit length, which is 2 pi r into current. This is the magnetic field due to a toroid. All these things you should know. Right? So let's do some questions. A long solenoid of some radius, 100 turns per millimeter, 1 ampere current flows in the solenoid. Magnetic field strength at the solenoid center is how much? Okay. So obviously magnetic field formula for a solenoid we have to use, because it's clearly mentioned solenoid, mu B is equal to mu naught Ni. Mu naught is 4 pi into 10 to the power minus 7. Number of turns per unit length, 100 turns per millimeter. So per millimeter is 100. 1 meter has 1000 millimeters. So into 10 to the power 3. Understood? This is per millimeter. But every time you should be using SI units. So 1 meter has 1000 millimeters. So there will be into 10 to the power 3 turns. And current is how much? 1 ampere. Yes. So 10 to the power 5, 10 to the power minus 7 will make it 10 to the power minus 2. 4 pi into 10 to the power minus 2. Yes, just check this out. 4 pi will be 12.56 and yes, so it should be option 3. 12.56. 12.56 exactly. Yep, very good. Excellent. Moving on to the next question coming up on your screen. Here it is. A long wire carrying steady current is bent into a loop of 1 turn. The magnetic field at the center is B. If it is now bent into a circle of n turns, the field at the center of n turns will be how much? Okay, let's have a look. Why change that t-shirt? Gokul, just ऐसे ही है ना? Every day wearing same t-shirt also boring, no? And I also need more shirts, or else the clothes have to come out from washing and all that. And this is also very cool. I don't think you can see this shirt completely. I'll have to stand like this maybe. Yeah. So yeah, it's a very cool shirt. I like the color. I just wish this had some color, so I'm getting some more t-shirts which look nice. And by the way, you too can order these shirts. For it's available. Even I have ordered this shirt from the Vedantu store. So there is a Vedantu store. I don't know how many of you know this, which has a lot of things, which has a lot of merchandise, bags, this, that, books, Tattva books, PYQ books, material to download. It's like your app store or like your Google store. There is a Vedantu online store where you can buy a lot of stuff. There are a lot of cool stuff and a lot of useful stuff which you can buy. So check that out. Just search for Vedantu store. So the magnetic field at the center of the coil of n turns will be, okay. So you have a wire of certain length, you turn it into a coil of 1 turn, some radius. Magnetic field will be mu naught I by 2r. Now what is this r going to be? Because this length will be 2 pi r. So this small r will be L by 2 pi. It will be L by 2 pi. So it will be mu naught I by 2. Instead of r, you use L by 2 pi. Just leave it as it is. Don't do much. Now what you do, you make that wire into a coil of n number of turns. Into n number of turns. And the radius will be something else only. Here 2 pi r into n number of times will be the length of the wire. So r will be L by 2 pi into n. So the magnetic field will be mu naught I, but n number of times because n turns are there, by 2 into r, but that r this time will be L by 2 pi n. So this will become mu naught I into 2 pi divided by 2L into n, which is n square. This value, do you see? Whether this is B prime. This value, do you see what it is? Mu naught I by 2L, 2 pi, mu naught I by 2L into 2 pi. That is your old magnetic field B. So what do you have? B into n square. So B into n square, where is it? Option number 2. Yes, that is the correct answer. That is the correct answer. Got it? Answer Cheppendi, answer Solonga in the chat box. Flirting Kadu. No flirting, no random chatting. Concentrate. Yes. Yeah. Moving on to the next one. An electron moving in a circular orbit of radius r makes n rotations per second. The magnetic field produced at the center has a magnitude. How much? Electron is moving. Electron is moving, guys. Electron is moving, right? Electron is moving. And the question is, find the magnetic field at the center of it. Well, this electron moving is like a current. So it is charged by time. Charge is E. Time is, okay, n rotations per second. So the frequency is n. Time period will be 1 by frequency. So it is 1 by n. So that time will be 1 by n. So it will be basically En. Now the real question is finding the magnetic field. Magnetic field is mu naught I by 2r. So mu naught is there, 2r is there. Current is basically En. So mu naught En by 2r. Mu naught En by 2r. So that is basically option number 4. What a simple question, but direct application of formulas. So these kind of questions are definitely going to be there. Moving on to the next one type of question, guys, Faraday's law and Lenz's law. Let's try to do as much as we can. Quickly, concentrate. Let's go ahead. Yes, clear, captain, says Gokul. Very good. Awesome. Faraday's law and Lenz's law. For Faraday's law, the EMF is basically d phi by dt, magnitude wise, rate of change of magnetic flux. This is magnetic flux, which is magnetic field into area. And Lenz's law, based on the conservation of energy, says that the current induced or the EMF induced always opposes the change. So if the field is trying to become strong, the current will try to make it weak. Like if somebody is studying very well, you will distract him. Hey, listen, let's play this game, let's hang out. And you pull him down. If somebody is very weak, not studying, you motivate him and you make him, study. So that is what Lenz's law is. Okay, conservation of energy. All right. So magnetic flux linked with the coil is given by the equation phi is equal to phi t square plus 3t plus 60. The magnitude of the induced EMF at the coil at t is equal to 4 seconds is how much? Okay. So flux is given, induced EMF at 4 seconds. EMF is d phi by dt. Flux rate change is EMF. That's Faraday's law. So derivative of 5t square plus 3t plus 60. 5 is 5, t square's derivative is 2t, 3's derivative is 1, 60 derivative is 0. So it will be basically 10t plus 3. So that is the answer. But we have to find that t is equal to how much? 4 seconds. So substitute time as 4 seconds. So 10 into 4 is basically 40 plus 3, which is 43 volts. Yes, option number B or 2. That is the correct answer. Very good, Retro. Awesome. Pugularasan, Shrishtail. Yes, that is the correct answer. Very good, Soumya. Yes. Oh my God. Mr. Sadness, why are you so sad, man? Rose sarge line kodta ho. What and all is going on in the chat? Next level stuff. I will only not understand. Something and all is going on. Okay. 800 turn coil is having area and is kept perpendicular to the magnetic field. When the plane is rotated by 90 degree, then how much EMF is induced in the coil if it happens in 0.1 seconds? Okay. So the coil is kept perpendicular to the magnetic field. So the coil is kept perpendicular to the magnetic field. The magnetic field is like this. So obviously the area vector will be like this. Perfect. Now you turn it by 90 degree. That means the area vector will be parallel to the magnetic field. So there is a change in flux. Clearly we can find that change in flux to find the EMF. EMF is del phi by del t. So it is final flux minus initial flux upon time. Final minus initial flux by time. Final flux is B A cos 0 because angle made between them is 0. Initial is B A cos 90. Whole thing divided by delta t. Cos 90 is 0. Cos 0, 1. So this is going off. So it will be just B A by delta t. But wait a minute, be careful, there are 800 turns. So do not forget that 800 or else you'll get a completely wrong answer. So when you're finding the flux, number of turns will also come everywhere. So just substitute magnetic field 5 10 to the power minus 5, area 0.05, time 0.1, number of turns 800. So just substitute it, you will get the correct answer. What is the correct answer that you will get? Just check it out. If you are getting it as 0.02 volts, yes, solve this, you should get it as 0.02 volts. Standard model questions, guys. These are standard model questions. Sir, ni problem solve ayinda? Manoj Raidu, meaning? Yeah, I'm solving the problems only. Or maybe you can ask it in English so that others also can understand. Okay, right. What is it? Next one. Motional EMF, meaning you take a rod of some length conductor and move it with some velocity in the magnetic field. Then there is EMF generated, some polarities you can put. This rod behaves like a battery. This rod is going to behave like a battery. That EMF is called as motional EMF because the rod was under motion. The formula is basically L dot V cross B. V cross B. That is the formula. Now, when your rod is basically, perpendicular, velocity is like this, and the magnetic field is also perpendicular, then the EMF which is generated is simply LVB. It is simply LVB. Please keep that in mind. If it is not perpendicular, maybe it is, and some other angle, maybe the rod's length is only like this, then the EMF produced is 0. So use this formula. It is very easy to find out whether EMF is generated or not generated. That too, it comes in a very simple way using cross product and dot product. First do cross, then do dot. Okay? Right. All right. Thank you, Shruti, bless you so much. Let's see what the questions are going to look like. There is a wheel of certain radius rotated with some angular speed. This rotation based questions also do come. So in fact, I can put up a slide here. This was when the rod is moving with speed v, but if the rod is rotating with angular speed omega, then the EMF generated is B omega L square by 2. This is the formula. Directly you can use it when it is rotating to find how much EMF is generated in this particular rod when it is moving in the magnetic field. Okay. So same thing is asked. It is rotated with some speed. What is the EMF generated? What is the EMF generated? EMF generated is half B omega L square. B is how much? 0.1 Tesla, omega 10, L 0.5 square. So this will become 0.1 into 10, 1. So 0.5 square is 0.25. So it will become 0.125 volts. Where is it? Yes, 0.125 volts. Option B or option number 2. That is the correct answer. Yes. Yes, Virati, that is correct. Perfect. Then there are also these questions on inductance which are very, very common, which you should know. Like for self-inductance, the flux passing through that coil is proportional to the current in that coil. That constant of proportionality is called self-inductance. In mutual inductance, the flux passing through other coil is proportional to the current in some another coil. So that is M into I1. That is how it works. Also, phi1 will be M into I2. That is the coefficient of mutual inductance. Bear that in mind. Here, if I do d phi by dt, I'll get EMF generated across it, which will be, again, L di by dt. This is again magnitude wise only. Same way, EMF generated across them will be M times di by dt. Perfect. Magnitude wise. Energy wise, the energy stored in an inductor is given by half Li square, and the energy density in that inductor is half B square by mu naught. That is the formula. Half B square by mu naught. Mu naught is the permeability. You should also know the inductance of a solenoid. The inductance of a solenoid is given by mu naught. Here you will have basically n square, and then you will have area. What else will be there? Mu naught n square and length. Yes, mu naught n square AL is the self-inductance of a solenoid. For a solenoid. Similarly, you have the mutual inductance of concentric solenoids. two solenoids, one inside the other. The mutual inductance is very similar, mu naught N1 N2 into area into length. That is the mutual inductance formula for concentric solenoids. For concentric solenoids. Questions like this do come where current is there through an inductor, changes from this to this in 1 second, how much EMF is induced? Think which formula will you use? Think which formula will you use? Yep, the EMF induced will be L times delta I by delta T, right? L times delta I by delta T. The EMF induced is asked, self-inductance is 4 Henry, current changes from 4 ampere to 2 amperes. We are just interested in the magnitude, remember that. Anyways, final is 2, initial is 4, time taken is 1. So 2 minus 4 is minus 2. So 4 into minus 2 is mod, which is basically 8 volts. So 8 volts is option number D. Yes, that is the correct answer. This is 8 volts, right? So direct application questions. Next question on your screen. Inductor of inductance carries 1 ampere. The magnetic energy stored in the coil is how much? The magnetic energy stored in the coil is how much? That's the question. Yep. The magnetic energy formula is half Li square. L is given, is it? Yes, 10. Current 1. Oh, it is just that 5 joules. 5 joules. Option D again. How many of you wrote 5 joules? Option D. D for Dr. Krishna. Very good. Very soon. You guys are going to become doctors. Very nice. Next. Speed of light and energy in electromagnetic waves. Yes, let me tell you those formulas. Electric field magnetic field ratio is also maximum magnetic field ratio, which is the speed of light, which can be also written down as angular frequency by K, which is also frequency into wavelength, which can be also written down as 1 by permeability of that medium into permittivity of that medium. This is the main formula in electromagnetic waves which you should know. Also keep in mind, when you do electric field cross magnetic field, that direction is basically, I would say, parallel to the velocity of the light. Is parallel to the velocity of the light. Also in electromagnetic wave, the energy density of electric field is the energy density of the magnetic field. So the total energy of an electromagnetic wave is 2 times the energy of electric field, or it is 2 times the energy of the magnetic field. You can also get questions on radiation pressure. So the radiation pressure is I by C, intensity of light by speed, for absorbing surface, and 2I by C for reflecting surface. So radiation pressure based questions can also come. And the last thing in electromagnetic waves which you should know is the table of which rays are higher frequency, wavelength, etc. and their applications. It's there in NCERT. Like for example, this question, relative permittivity, relative permeability is given. Then what is the velocity of the light given by? Okay, speed of light in vacuum, this is in vacuum, is 1 by epsilon naught mu naught, but speed of light in that medium C prime will be 1 by relative permittivity into permittivity, relative permeability into permeability. So I can write it as root of epsilon naught mu naught separately, and here root of relative permittivity, relative permeability. What is this? This is speed of light. This is speed of light. That's it. So what is remaining downstairs is relative permittivity, relative permeability. That is your new speed of light in the medium. So C divided by relative terms in the root. Relative terms in the root, right? These are the kind of questions that you can get. Yeah. Another kind of question which we might get in electromagnetic waves, the magnetic field wave equation is given and they are asking you what the wavelength. Sometimes they ask you what is the field. So if they ask you the field, electric field, magnetic field, you know, E by B is basically C. E by B is C. So B you know, C you know, E you can find. Those kind of questions can also come. So here wavelength is asked, it's simple. This is basically K, and K is basically 2 pi by lambda is pi into 10 to the power 3, pi by, so lambda will be 2 into 10 to the power minus 3. 2 into 10 to the power minus 3 is option number 2. Yes, that is the correct answer. Yep. Awesome, awesome. A for Ames? No, this is not A for Ames. This is, the previous one was A for Ames. This is B for Shreyas Sir. Correct. Electromagnetic spectrum based questions, something like this. Arrange the following wavelengths properly. Who is larger, who is smaller? Who is larger, who is smaller? Come on. Arrange the following wavelengths properly. Come on, come on, come on. Quickly. Very straightforward. X-rays, infrared, micro and gamma. Gamma is very powerful. So the wavelength is smallest. Then I think X-rays will come, then infrared and then microwaves. Just check it out. Yes. Gamma rays most energetic, least wavelength, highest frequency. Then X-rays, okay, energy. Then infrared, even smaller energy, so large wavelength. Microwaves, very large wavelength, very low energy. Correct. Electromagnetic waves with the shortest wavelength among the following: ultraviolet, X-rays, gamma and micro. Ultraviolet, micro, large wavelengths only. X-rays, very short wavelength, but gamma rays are even shorter than that. So I think it should be gamma rays. Option 3. Yes. C for Captain Shreyas should be the answer. Gamma rays are the most energetic, highest frequency, shortest wavelength. Which color has the longest wavelength? Violet, red, blue, green. This is very simple. Violet has the shortest wavelength. Red is used for signifying danger because they have large wavelength, they have large reach. So that's how you should remember red color. Yes, red color, option number 2. Very good, very good. Now we have come close to the end. Hardly few more topics. I mean, questions are there. How about I give it to you as homework? Yeah, I'll keep it in the slides below over here. Is that okay? The slides are there. Just 2-3 more topics are there. You can just have a look at it. All right. So yes, let me just show you the end. Yeah, it's hardly done. Yeah, most of it was done only. So remember one thing, my dear warriors, that there is Vidya Utsav which is going to happen on 1st of May, and it is going to be telecasted live over here for all of you. And there is a massive surprise for all of you. So stay tuned on the channel, number 1. Number 2 is that as you are watching this video, keep this in mind that in the description box, and please thank you so much for making it 1000 likes, means a lot. In the description box, there is this very important link for all of you, AIMT, and this link will lead you to the free mock test series. And these kind of mock tests are very useful because same type of questions will get repeated in the NEET exam, and you will see that also same model questions last year also, this year also, the history will continue. So if you want the papers, you know, a replica or how the paper will look like, please use these mock tests. These are absolutely free of cost. Remember that. You'll also get analysis, report cards, everything. So you can make the best use of it. Not just that, there is a Telegram group link. So join it so that you will get the PDF of today's session. Cool. And of course, if you have not yet subscribed, click on subscribe and click all button. That's very important. Means a lot for you guys to, you know, be a part of this community. Feel proud about being a part of Vedantu NEET English, which is the largest NEET channel for, you know, South students. So make sure you are staying subscribed on this, right? So perfect. I hope you guys enjoyed this session, and stay tuned on the channel for the Vidya Utsav. A lot of surprises coming up for all of you, and all the best. Tomorrow 7 o'clock, and now after some time biology class is going to start. Quickly eat lunch and come back. Okay, I want you to be in full josh for Shreyas Sir's and Gopika ma'am's class, where all the scientists' names and the dates, everything are going to be given in one shot, crisp, small class. This is Captain Shreyas signing off. Hasta la vista.